you can give access for sharing the screen.
Yes, sir.
Okay.
So good evening to all respected resource persons, participants, and colleagues. It gives me a great pleasure to welcome you all to third day of Faculty Development Program, Master AI Applications from Classrooms to Boardrooms. As we move forward in our journey of learning, let us keep this thought in mind. AI is not about man versus machine. It is about man with machine. This simple yet powerful idea reminds us that artificial intelligence is not here to replace us, but to empower us. The true strength of AI lies in collaboration, combining human intelligence with machine intelligence to achieve more than either could alone. Through today's session, we'll continue to explore how AI can become our partner in teaching, research, and professional practices, helping us carry insights from classrooms all the way to boardrooms. So it is my honor to introduce our esteemed resource person for the day, Dr. Bhartendra Rai, Professor of Business Analytics in Charlton College of Business at University of Massachusetts, Dartmouth. Dr. Rai is an accomplished academician and researcher with expertise spanning applied deep learning, big data analytics, data mining, decision techniques, and operations management. His research interests lie in machine learning and deep learning applications, and his widely followed YouTube channel on deep learning featuring Keras and TensorFlow tutorials is assessed in over 225 countries worldwide. Dr. Rai holds a PhD in industrial engineering from Wayne State University, Detroit, along with two master's degrees specializing in quality, reliability, and operations research from Indian Statistical Institute. With more than 20 years of consulting and teaching experience, he has worked across industries including automotives, electronics, food, chemical, software, and defense. His professional journey also includes over 5 years at Ford Motor Company, focusing on analytics, quality, and Six Sigma. His contribution to research are published in reputed journals such as IEEE Transactions on Reliability, Reliability Engineering and System Safety, and Quality Engineering, among others. He has delivered keynote talks at international conferences and earned recognition such as Employee Award by FAIA for his PhD dissertation in support of Ford. He is also a certified ISO 9000 and ISO 14000 lead assessor and a Six Sigma black belt from ASQ. We wholeheartedly welcome you, sir. Sir, you can now start your session.
Thank you, Dr. Arora, for the introduction. And as I understand, I have time for about 90 minutes.
Sir, till 7:30 you have time.
Okay, thanks very much.
Okay.
So let me share my screens and I'll bring up my PowerPoint. Okay, so do you see my screen now?
Yes, sir, it is visible.
Okay, perfect. So welcome everyone. I see we have, I think, more than 50 participants.
Yes, sir,
So
the
that is...
number will increase. It will go up to 100 also.
Oh, okay.
Thanks.
Yeah, so that's very interesting because like when we make presentations at conferences, when we are discussing a paper, I remember one time when it's very difficult to get participants. And my session was there, and then there's one person who introduces the speaker, and then there was one more person sitting in the audience, so nobody else. So I was like, okay, so at least I have one audience. And I thanked him. So he said, like, don't worry, actually, I'm the next speaker. So, so those are the kind of things sometimes happen at conferences.
So we
But
have
I
a
think,
large number of participants. Yesterday, 144 participants joined. So they are joining. Actually, the time was 6 p.m. only. So they are joining right now.
okay, so this is very encouraging and it gives a lot of like positivity. So, okay, so my presentation is about artificial intelligence in supply chain management and operations optimization. And my name is Bharatendra Rai, and I'm from Charlton College of Business, UMass, University of Massachusetts, Dartmouth. So this is like about one hour by car from Boston, so not very far away from Boston. And I have been actually working at this college since 2006, about 20 years now. In the business school, I have been teaching business analytics, data mining, advanced deep learning, and many related courses. And before joining UMass Dartmouth, I worked at a Ford Motor Company. So you see in this picture Ramana Divakaruni. So he was my manager at that time who hired me. So I worked there for almost 6 years, and also Ford supported my PhD at that time, which was in industrial engineering at Wayne State University. And after leaving Ford, I came to UMass, and I've been there since then. We have worked with a lot of different companies as well, like we work with Professor Laura Forkert, Professor Tim Shea. With healthcare industries, we launched like MS in healthcare management. We are also launching a MS in healthcare analytics, similarly business analytics and so on. But it has been a very interesting journey. This is my PhD student who graduated in 2022, uh, doing PhD in industrial engineering, and her thesis was basically more focused on AI and machine learning and related applications. And these are some of my students, you can see, and some faculty members. So very quickly, the outline of today's session will be combination of the two, AI and supply chain. We'll start with the very basic understanding of supply chain. I'm sure everybody is aware of that and has good knowledge about it. I'll also talk about AI, and then this will not be like one-way kind of talk, but it will be more of an interactive session where more than 50% of the time you are expected to work with me on some hands-on activities. So make sure you are connected with internet. I'm sure you are connected with internet because you are on Zoom. So the only thing you need is access to some website, like either through Safari or Firefox or Google Chrome. Anything will do. So I'll get started with supply chain. So this is a very typical flow chart that I'm sure you may have seen earlier as well. And it starts with the supplier, like if you go from left to right, and ends with customer. But when we talk about supply chain, actually what activates a supply chain is the customer. So a supply chain always starts with the customer, although we see that towards the end. And all stages, whether it is a supplier or manufacturer or distributor, retailer or customer, so all the previous stages are basically involved in fulfilling a customer request. So for example, if I want to buy a camera, and I go to Amazon and look for some options, and then I decide to buy a camera for $500. So that $500 is the revenue that Amazon will get, but then it gets distributed across the entire supply chain in certain way. So lot of information is involved. There's a flow of information, flow of products, flow of funds throughout the supply chain. When I used to work at Ford Motor Company in Detroit, I remember I was with the North American diesel engines, and as you may know, engine has like more than 700 parts, and Ford does not make each and every part. In Detroit, they have like hundreds of suppliers. Like they may get engine from International. There's a company in Chicago, and International Incorporation may get their fuel injectors from Siemens. Similarly, those fuel injectors, some smaller parts, maybe rings or something, may be supplied by another supplier. So there is a very big chain of suppliers that basically works to fulfill something that finally goes to a customer. So the main objective of any supply chain management, when management comes into picture, is to maximize supply chain surplus, which is the difference between customer value and supply chain cost. So customer value is that money that comes as a revenue, like the camera that I mentioned, $500. Customer pays $500, and because a customer values that camera at that 500, or maybe expects that they are going to extract more value, so they are ready to pay $500. But then to fulfill that customer need or want, so many actors are involved in the supply chain. So there's a transportation, there's a retailer who is like keeping it somewhere till it gets sold. Somebody is manufacturing it. So all those cost money. And as long as the customer value is greater than the supply chain cost, so a business or a company is profitable. So there are a lot of examples you may have already like come across. I will just list a few here. Like Walmart is a very interesting name. Anybody who teaches supply chain management, I'm sure when you teach supply chain management, you give examples similar to some of these. And Walmart is known for a very, very efficient supply chain. So from $1 billion in 1980, they have grown to more than $600 billion in 2024. And I have this video. Let me see if I can play. You can see this simulation where the distributors are growing from one place, and then it spreads out all across US. And while watching this, you may notice a pattern that when there is a dot at a new place, there are dots surrounding it. So basically, the idea behind that is like Walmart should be able to replenish their products or items with minimum cost. And they can significantly reduce transportation costs when the distributors or the people who are filling the shelves are close by. And that's something most of the people do. Like if you look at big automotive companies, let's say in Pune, India, you have Tata or Bajaj. So their suppliers are actually located very close to them. I remember in my consulting days in India, where I worked with like hundreds of companies, and also like many US many suppliers to automotive companies. Like there was a Ponce Autocom, and they were located like you can stand there and see Tata very close, because if you are very far, then transportation goes up significantly. 7, and they went from 1 billion yen to 12 trillion in 2024, from 74 to 24, you can see. And they are also very effective when it comes to minimizing the supply chain cost. That second number in that equation, customer surplus minus the cost. So they are also very well known for minimizing that cost. On the other hand, there are so many examples where a company did not manage supply chain well. And Webvan, for example, they had excellent idea of delivering fruits and vegetables, actually, or groceries, to individual houses from big warehouses, but they were not able to manage the cost, transportation costs and other costs efficiently, and they folded or went bankrupt within 2 years. Borders was a very well-known company in 2004, and they had to close everything after they failed to compete with the efficiency of supply chain of Amazon. Dell, for example, was doing well, but it has not grown much. Like if you see, only like 56 to 88 billion in so many years. So supply chain plays a very important role, like how you manage, how you minimize the cost, basically the second component of the supply chain. So that becomes very critical. So this slide basically relates that to the importance of decisions that are made at various stages. So if you look at this triangle, there are some decisions that are made at maybe supervisor or lower management level, and those are like day-to-day decisions. Like if a company has like 24 machines, who will work on which machine, what kind of products will be made. So there are lots of decisions. So that's why the area is bigger. But as you go up, like design related supply chain decisions, although maybe less in number, but they can have huge impact in terms of cost. So decisions that are made here, typically like those people are involved, like senior management, and the impact could go on for several years. Whereas people who are at supervisor or like lower management level, their decisions may not have that huge impact. So for example, I remember I worked with a consulting company in US, and so basically they were working with the big uh, European company who had their barges full of wine bottles coming to US at New York port, and they had one warehouse located on the west coast in California. And to reduce their transportation cost, they were planning to have one more warehouse. And location, basically, they were trying to figure out like whether they should do that in Chicago or like somewhere south, Florida or Michigan, something like that. And for that, we were collecting data and trying to basically compare different scenarios. Like if you open it at this location, what will be your supply chain cost? Versus when you open it at location B, what will be the supply chain cost? And one of the methods, I'm sure like many of you who are teaching this course, one of the method is center of gravity method, which like we teach in undergrad. But we use that tool basically to compare those options and finally make a decision. But then once that warehouse is opened, so it's not that you can just, if things go wrong, you can just cancel the project and move to some other location. So it is a very time consuming, and a lot of money is already invested. So that can have a huge impact for many, many years. So there are two popular views of supply chains. One is cycle view, where you have like things start at one level and then there's a cycle, like there's a supplier and customer relationship. So I go on Amazon and I want to purchase a camera, a $500 camera. So uh, the cycle between me and Amazon, so that is one cycle. So Amazon is the supplier, I am the customer. Then there's another cycle, which is where Amazon is the customer and they are getting the camera from a manufacturer or warehouse, whoever it is. So there's a cycle like that. So that is one view. And other view is the popular push and pull view, where pull is execution is initiated in response to a customer order. So everything starts happening once there's a customer order. So that is pull. And push is execution is initiated in anticipation of customer orders. So you figure out like what the customer is going to buy and then and how much, and then you start making them. So to do the pull thing is very good on paper, but it's also very difficult because the supply chain has to be really, really efficient. If it is not efficient, then things are not going to work out. So there are a lot of examples. I'm sure you also cover in your courses. But the key questions that comes to mind when we are talking about supply chain management are some questions like these. So where should the plants be located? So this is Toyota. And what degree of flexibility should be built into each? What capacity should each plant have? Should plants be able to produce for all markets or for some specific contingency markets? How should markets be allocated to plants and how frequently should this allocation be revised? And how should the investment in flexibility be valued? So all very relevant, but very supply chain related questions. And then those actions have huge impact on supply chain cost. Similarly, Amazon, what problems or issues they try to tackle or what questions they try to answer? So should Amazon stock every product it sells, or what advantages or disadvantage does online channel enjoy in the sale of shoes and diapers related to retail store and things like that? So these are like very typical questions where like the concepts of supply chain management come into picture. Now switching gears, let's briefly talk about artificial intelligence. So I remember watching a video like sometime back, YouTube video where Steve Jobs, who started this company called Apple, so he was giving an interview in I think 80s or 90s, so very old interview, and he was giving an analogy where he was talking about a study reported in literature where somebody studied locomotion, basically like how much energy or with how much efficiency various animals or species move from location A to location B. So there are a lot of animals, like for example, horse can move from one place to other place very quickly. Maybe elephants may not. So in that list of efficiency, humans were way down. And then somebody repeated that study with a human on a bicycle. So bicycle is a tool, and with that, the humans came at the top. So they left everybody behind in efficiency. So he called the computer at that time basically bicycle of the mind. So he used that study and called computers that computers are bicycle of the mind. So he was talking about computers in 1990. So this is Apple, and it had a RAM of 1 megabyte and storage of 40 megabytes. So that was like, at that time, it was unheard of technology. So much space, you can store like almost everything. So that was 1990. But today, things are different. If you compare, this is a IBM supercomputer, mainframe computer from 1960, and there are two scientists who are operating this computer. And in 2025, even our smartphones are much, much more powerful than those computers. So technology has come a long way, and that has allowed a lot of things to be implemented for improving productivity. And obviously, like from time to time, there are, anytime something new comes, people try to challenge it or find faults or try to say that there are a lot of dangers involved. So that reminds me, like I read somewhere, I think it was Plato, who is a great thinker. So he mentioned at some point that Socrates, another great thinker, was worried that writing will make people's memory bad. Like people will not remember things if the technology like writing becomes like common. So that was a time, like even writing, they thought that it can spoil people. And I remember in US there was a time when calculators were banned in schools because it will spoil kids. Kids will not learn like properly how to add, multiply. So calculators were banned, but everybody knows that like when you're using a calculator, chances of making a mistake is removed. So AI is, I think, at that stage where people are talking about it in so many different ways. Some are positive, some negatively, some are scared that it will lead to all kinds of things. Even like anytime a new technology comes, one major problem people talk about is people will lose jobs. Okay, so this is actually from last week, where I think China conducted this robot Olympics, where all these robots are competing in 400-meter race or 400-meter relay and things like that. So there were 280 teams from 16 different countries that participated in these Olympics, where robots were competing with each other. So these are all terms that I'm sure you have heard of. Artificial intelligence is like bigger umbrella, and then within that you have like subsets. So when I look at artificial intelligence, I look at it as a basically productivity improvement tool. So you can use artificial intelligence to do things faster. If I have to, let's say I'm writing a paper, research paper, and coming out with the first draft takes a lot of time. And if I can uh, use some kind of AI that can speed up things so I can be more productive. So that's the idea behind artificial intelligence, where people are coming out with technologies that can make people save a lot of time. We have driving cars now, not just Tesla, but you have Waymo through Google, and you sit in the car and the car drives itself. So just this weekend, we went to Vermont, and it's almost like 300-mile journey. It takes 5 hours. And the good thing is that because the car is driving itself, you don't feel tired. So you're just sitting there, you're listening to audiobook or talking to somebody on phone, but you don't feel tired because you're not constantly driving the car. So it improves my productivity in a way, and also like cars have become smarter. Like sometimes it will say that because you are driving 300 miles and you have only like less than 300 mile of battery left. So this is the place you have to charge. And while driving, it figures out that actually because of maybe downhill or whatever, it gains some, and it will change the map automatically saying that you don't really need the charge. You have enough charge. So things are like those kind of things also make it smart. It gives them some kind of ability to no, I don't want this. I just want to keep the way it is. Intelligence has been implemented in so many different ways using so many different tools. Machine learning is one, and you must have heard of methods like extreme gradient boosting. How many of you have heard of Kaggle? Anybody uses Kaggle? Kaggle? Anyone? Kaggle is a repository of data sets. So some people are mentioning they are aware of it. So Kaggle is a platform where like a company, they want to solve some problem, they can provide the data. So let's say Netflix wants to improve its algorithm of making recommendations. So they may provide the data, and obviously as a challenge, and give maybe 3 months or 6 months of time, and people can go there, download the data, and try to build a model that can do better than what Netflix is doing, and also like win some prizes. Like I have seen prizes like $500,000 or sometimes hundreds of thousands of dollars. But I encourage actually my students to go on Kaggle and participate in those competitions. One, to gain experience with the real world data, and if they get interest and if they land in top 10% of the Kaggle uh, leadership board, so there will be so many companies that will be after somebody who is like in top 10% of Kaggle, because these people have rare skills, and those skills are very, very much needed by many companies who are trying to implement artificial intelligence in their companies. So one thing I have noticed on Kaggle is people who have won competitions and shared like what they did. So typically, if it is a classification problem with the data or a prediction problem with the data, one of the machine learning methods, or popular machine learning method they use, is extreme gradient boosting. So that is one of the most popular among the. Similarly,